Here we go. We've been working with polygons and specifically quadrilaterals. We've done a number of, this is the rule, we can derive the rule, we can apply the rule. Today, what we're going to be doing is building these shapes, constructing them. And you'll remember that constructions are a way of proving something is true by simply using these two tools, a straight edge without any measurements on it, and a compass. I'm going to walk you through this. I'm going to use a bunch of different colors along the way to help you kind of see things, but generally, these are the tools. We're going to start by constructing a parallelogram by definition. So what is the definition of a parallelogram? Two sets of parallel sides. Now, this first one we're going to do, box 1 of 12, is the hardest. So I need you engaged, I need you to stick with me, and I need you to tell me if you're falling behind. To begin with, if we're going to create parallel lines, we need a line to start with. So everybody take your straight edge and draw a line segment. Now, as we did before, when we did the parallel lines unit, we discovered that if I have a line and a transversal, that if I can produce angles that are congruent in certain relationships, that I can get parallel lines out of it. So draw yourself a transversal. The angle that it falls doesn't really matter. It should look something like this. Along this transversal, I want you to put a dot. The dot should be less than halfway away. In other words, closer to the line than it is to the end of the segment. And our goal here is to copy this angle. Because if we can take this angle here in the corner and put it up here, what's the relationship between those two angles? Well, if I copy it, they'll be congruent for sure. What do we call those? Are they same side interior, alternate exterior, corresponding? Corresponding. So if I can get corresponding angles that are congruent, then the line produced will be parallel. So what I'm going to do is take my compass. It's got a needle end and it's got a pencil end. The needle end I'm going to put right at the point of intersection of our original line and our transversal. And I'm going to adjust the size so that I can make an arc before that dot I put on my transversal. And I'm going to make that arc. And I won't touch my compass because I'm going to use that same size again. I'm going to move my compass up so that now the needle is on that dot I made. And it's still the same size, the same radius as the one I just did. And I'm going to make another arc, this time from my dot. These two arcs are congruent. They both represent the same radius circle. And what I want to do then is find out how wide the mouth of the arc is here and copy that up to here. So I'm going to take my compass and I'm going to stick it right on this point of intersection where the first arc meets my transversal. There's my needle. And I'm going to extend my compass until it gives me just the right size to meet the point of intersection over here. In other words, where the arc hits my original line. And I'm going to put a little mark there to show that that's where it hit. And again, my compass is now set. I don't want to touch the wheel and adjust it right now because this is the length that I need. Now I'm going to come back up to my second arc, my copy. And I'm going to put the needle at, sorry about the camera, at this point of intersection. And I'm going to try to find where it is that it crosses here. Question, Jack?
How are you supposed to make the little dash at the bottom?
You do adjust the compass. When I come to here, I'm going to put the needle on this mark where it meets, and I'm going to adjust my compass until it just barely reaches right where the arc crosses the first line, and I'll make a line there. So I did adjust it to find that length. Now that I've found that length, I don't adjust it. I keep that length in my compass. And I'll put the needle on this point of intersection of the arc and the transversal. And I'll see where it meets. My little circle was a little bit off. It's a little bit higher than that. But that point of intersection, when I connect it with my dot over here in my transversal, should provide me with a line that is parallel to my first line. I put it through the dot and through the crossing of these two arcs. Please check with your neighbors and make sure they're having success with this. You can either raise your hand or ask a neighbor. Anyone need more time creating this first line parallel? Okay. If we're trying to create a parallelogram, we've successfully created one parallel line pair. Now we need a second one to be parallel to this green. I think it's helpful to actually turn my page. You don't have to do it this way, but what we're going to now want to do is copy an angle from here up this transversal here to create another line parallel through there. So what I'm going to do is I'm going to suggest that I want to copy this angle here. And so I'm going to go up this transversal a ways, maybe there, put a dot. Again, ideally it's less than halfway. That gives me room to make my arcs. I don't have a lot of room here though. So I'm going to extend the bottom part of my original transversal here. And again, I'm going to copy this angle and put it right up here. So first, put my needle at this point of intersection. I can choose any size I want. I just have to make sure it hits. I suggest you make it shorter than that dot is up the line so it falls shy of it. Make an arc. And then pick that up without changing the size. Put it in your second dot here and make a corresponding arc. Now I want to find out how wide the mouth of this arc is, my first angle. So I'm going to use my compass to span the gap. Going from that point of intersection, I'll have to open it up to get to this other point. Set it at just the right size and make a mark to show that I pulled it from here. And then pick that up and carry it up to this other one and leave a corresponding mark. That point of intersection should be able to be connected with my original dot to give me a line parallel. Now I've got this purple line, the new one, is parallel to the green line. And I've successfully created, by construction techniques, a parallelogram from the definition. Now again, that was the hardest one we'll do, is constructing a parallelogram by definition. It is a parallelogram, but it's got different features, right? What's the definition of a rectangle? Well, it's actually a quadrilateral with 4 right angles. Sure. It's a quadrilateral with 4 right angles. Now, could I define rectangle as a parallelogram with 4 right angles? I could, but that would mean that when I'm trying to prove it's a rectangle, it'd be harder. I'd have to first prove it's a parallelogram, then prove the right angles, when in fact, this is sufficient. All right, so step 1, let's get our free line. Draw a segment down below. This is free. We know it's going to be straight. Next step is on the end points of this segment, make an end point 1 and an end point 2. And then what is about halfway, put an end point. It's actually not an end point. It's a point in the middle called 3. Midpoint, but it's not actually midpoint, right? I'm just guessing where it is. Now what I'm going to do is I'm going to construct a perpendicular line right between 1 and 3, a perpendicular bisector. You might remember how we do this. If not, it'll probably come back in a moment. I take my compass, I anchor it on 3 with a needle, and I choose a length that is more than halfway. It can be 2/3, it can be 3/4, it can be 52%. And I'll make an arc. Then I pick up my compass, move it over to point 1, not adjusting the radial size, and make another arc. And I get this famous football that we use a lot of. If I connect the end points of that football, I produce a line that is perpendicular. It also bisects the segment from 1 to 3, but that doesn't really matter to me, just as in happenstance. Now I'm going to do the exact same thing between points 2 and 3. An anchor on 2, go more than halfway to 3, make an arc, come back to 3, use that same size to make another arc, giving me my little football. Connect the endpoints of that football, and that gives me another right angle. So I've got 1 right angle, 2 right angle. I need 3 and 4 right angles. So what's going to happen is, again, I'm going to swivel my page. I'm going to turn it around, and I'm going to do a perpendicular bisector right here. Where? I don't know. I guess I'll go with a point here and a point here, and it's going to make me go right in between those, and it's going to be about there. So I just randomly threw a couple points on there. And I do the same thing we just did. I'm going to go more than halfway between them. Make an arc. The same length from the other endpoint, giving me a football. 2 points of intersection. And that gives me my 3rd right angle. Again, just 2 random points, and then go more than halfway to make an arc, that same distance from the other one to make an arc, connect the endpoints of the football. Now, how am I going to find that 4th right angle? Isn't it already there? There's nothing I can construct to make it there, because this is now a quadrilateral. What's the sum of the interior angles in a quadrilateral? 360. I've already got 90, 180, 270. So if I take 360 minus 270, that is 90 degrees. I don't have to do anything more. That's 4 right angles. Any questions on constructing a rectangle by definition? A little bit easier than parallelogram? Yeah, still tough. Let's do an easy one. Build some confidence here. We're going to construct a rhombus by definition. What is the definition of a rhombus? Good. It's a quadrilateral with 4 congruent sides. I hear some people bringing in some other attributes that are true about it. Diagonals are perpendicular, opposite angles are congruent. There are some things that are true about it, but we don't want to complicate the definition. If we build all that stuff into the definition, then when I want to say something is a rhombus, I'd have to prove all those attributes are true for that shape. This is the bare minimum that makes it a rhombus, 4 congruent sides. So that's what I want. This one's really easy. I want you to take a point about there. Take another point about there. Draw 2 points diagonally oriented in your open space. Put your compass needle on the bottom point and open it up, open your compass up so that it's more than halfway. And make an arc. Can we agree that every single point along this arc is the same distance away from this lower point? Right? That's what a circle is. It's all the same distance from this central point. Pick up your compass, reduce the radius, make it smaller, and move now to the upper point. I'm going to make it much smaller. I still have to make sure it goes over my previously drawn arc, but that's all it's got to do. Oh, no. I've done this wrong. What did I do wrong? Are both of these points the same distance from point B down here? They sure are. Are both of these points the same distance from A? Yeah. But is this point the same distance from A as it is from B? No, that's where my mistake is. I should have made these 2 circles the same. Sorry about that. I'm going to erase my circles. I'm still going to have my yellow spots there.
But it's not how they work.
I'm sorry?
It's not how they work. Like, oh, wait, no,
that would have made a kite. We'll get to that later. So what I needed to do was go more than halfway and make an arc. And then keep that length. Don't change it to smaller. And go from A that same length. Are these 2 orange points the same distance from B? Yes. Are they the same distance from A? And if I made those 2 radiuses the same, aren't they the same distance from all 4 sides? So connect the dots. Okay, so that's our rhombus from definition. What about square by definition? What's the definition of a square? With 4 right angles and 4 congruent sides. Let's start with a right angle. That means we need 1 free side. And we're going to have to go up to create a perpendicular. It doesn't matter what endpoints I choose. I could choose the endpoints here, and I'd get a perpendicular bisector going up the middle. I'm going to choose 2 points that are closer together. Yep, all that's going to mean is that when I produce my perpendicular bisector, it's going to go halfway between these 2 points. Because I chose random points, where this line is isn't important. I'll go more than halfway, make an arc. That same distance here, make an arc. That gives me my football. And I connect that football. And that's going to give me my right angle. Now, if I end up producing 2 more sides over here to make my square, if I can make it a rhombus, what do we know about opposite angles in a rhombus? They're congruent. So if I were able to make a rhombus over here, and this is a right angle, what would be the angle over here? Right. And what do we know about consecutive angles in a rhombus? So if this one's 90, how much would the other one be? 90 also to make 180. Therefore, once I've done 1 right angle, all I have to do is form a rhombus here. So I'm going to take my compass, insert it at this spot, and say, I don't know, I guess I'm going to go that far. Oops, except I missed. My needle slipped as I was trying to show you here. So it's right there. And I'm going to make a mark here. That's telling me how long my square is going to be. So I'll also make that mark going up. So now this side is the same as this side. Now I can go to this point of intersection, and I don't know exactly where my 4th point is, but it's got to be this same distance away, right? Because it's this length, which is the same as this length. And if I go to this other point of intersection, it's got to also be that distance away from this point. That finds for me a point of intersection. And if I connect all these dots, I should use a different color. That will give me my square. Because I forced this side to be the same as this side, to be the same as this side, to be the same as this side, I know that this is a square. Let's flip to the second side. We're now going to unstruct isosceles triangle. It's actually construct. The C just came off. Isosceles trapezoid, excuse me. What is the definition of an isosceles trapezoid? By the way, when I ask what these definitions are, is this hard for you to pull out? To find it? Go to the last page in the packet I put in front of you. Right? This is everything. So if you don't know this off the top of your head yet, use this last page. So when I say isosceles trapezoid, the definition is what? One pair of parallel sides, because it's a trapezoid. And Canyon was giving us the second? Non-parallel sides are congruent. So we're going to have to do those parallel sides again, like we did for the parallelogram. Just one set, though. So start with a side. Give yourself a transversal. Give yourself a point that's not quite halfway up that transversal. And again, we're going to copy this yellow angle to the corresponding location. And if corresponding angles are congruent, the lines will be parallel. I'm going to take my compass and put it right at the intersection of my line and my transversal. Adjust it so it's a little bit below the dot. And make an arc. It's my reference arc. I'm going to pick that up and carry it up to my red dot here. And make another one. Same size. I've got two congruent arcs here. Now I have to figure out how wide this mouth is. So what I'm really doing is I'm measuring from this point of intersection to this point of intersection. I'll copy it up to here and figure out where it's supposed to be there. So I'll put it on the point of intersection here, adjust my compass until it goes right through that point. Then I'll pick it up and move it up to here and show where that point is supposed to be. Yep, I overestimated again. I thought it'd be down lower, but it's actually up there. When I connect these two dots, one's the point of intersection, one's my starting dot, they should be parallel to the line I started with. Now, we got one set of parallel lines here. How am I going to find out what the other piece is? It said non-parallel sides are congruent. So I'm going to take my compass and I'm going to find out exactly how long this non-parallel side is. Open it up to get just the right length. Make a mark showing it. And then I'm going to put that over here somewhere. I don't know where. I guess I'll just put a point here. I'm going to put it there. When I put the needle there and mark, what I find is that it actually hits my parallel line in two places, right? It hits once here and once here. Let's call this point 1 and this point 2. If I connect this to point 2, what kind of shape am I making? Parallelogram. Because doesn't a parallelogram have opposite sides congruent and parallel lines? But if I go this way, what shape am I making? Right, an isosceles trapezoid. So that's the one I want to connect. I now know that this line is parallel and this side is congruent. Any questions? All right. Next one, constructing a kite by definition. Wait, we've never talked about kites. Go to page 4 in your packet. You'll see that it's actually here. All about kites. The definition of a kite is one pair of parallel sides and another pair of parallel sides, but they're each adjacent rather than opposite. So let's come back here. Definition is two pairs of consecutive congruent sides. This is the one I made a mistake and did earlier. Give yourself 2 points. One up here, one down here. From the lower point, go more than halfway. I'd say go significantly more than halfway. Go like 3/4. Make your arc. Then from the other point, reduce your radius significantly. Make it smaller. Just make sure it'll cross over the arc you've already drawn. It should cross over twice. And again, can we agree that both of these yellow dots are the same distance from A? Because they're part of the same circle, right? And both of these dots are the same distance from point B. But A to the yellow is not the same as B to the yellow. That's what we want. So I'm going to connect these points. And again, let's show what we did. We made these two sides congruent and these two sides congruent. Five, I can do all 6 of these myself. 3, if this is what it took to get off the desert island alive, I could figure it out with my notes. 1, I like coconuts. That'd be all right. Okay, good. Now, I don't think the way we've done these so far are the easiest ways. I think particularly the parallelogram is quite hard. So I have a different way of doing it. We're now going to construct the parallelogram by diagonals. Here's where you might need your little note sheet that's on the last page here. What's true about the diagonals in a parallelogram? Try again. They bisect each other. Diagonals bisect each other. And is that also true for a rectangle? Do they bisect each other there too? Sure, because rectangles are parallelograms. So anything that's true here is also true here. And someone made a comment that diagonals are congruent. That's true in a rectangle. Remember my window installers? That's the difference between rectangles and parallelograms. In a parallelogram, diagonals are not necessarily, I mean, I guess they could be, but if we're looking for a shape that is best classified as a parallelogram, the diagonals would not be congruent. So how can I get diagonals that bisect each other? Well, let's do this. Everybody find the middle of your box here. And take your compass, anchor the needle on that dot, and make your compass as big as you can fit without going off the paper into the words. A nice big circle. And now I want to create a diameter. What's a diameter? Good. I'm going to pick some point on the circle's edge, and I'm going to go from that point exactly through the center to get me to the other side, and stopping on the rest of the circle's edge, the other side's edge. That's a diameter. And what is that midpoint? Doesn't this center bisect this diameter? Because the radius is the same on both sides. So that's what we wanted. Diagonals bisect each other. We've now got a bisector of this diagonal. Could we do it again in a different direction? Like, let's say we go there and connect from that point through the center. Is that also bisected? So do I have two bisected diagonals? But wait, I'm supposed to have diagonals that are not congruent. These are congruent, aren't they? So watch this. Take your needle, put it back in the center again, and reduce your radius. Make a smaller circle with the same center. That's called a concentric circle, to have the same center but a different radius. And what if instead of taking that green radius or the diameter all the way to the outside, what if I stopped it here at this other circle? But I left these blue ones go all the way to the original circle. Are these diagonals now both bisected and yet different sizes? Connect the dots. So these are bisected. This is bisected in a different width. That's a parallelogram. Is that a little bit easier? Yeah, right? Let's move back over here to the rectangle. Do we still need diagonals to bisect each other? So let's do the same thing with the circle again. Put it in the center, make it as big as you can. Draw one diameter. And that one's bisected, right? What do I do for the other one? This time it says diagonals are congruent. Do I need a different circle? Can I use the same circle since they're supposed to be congruent? Same circle, right? Just pick some other spot. Draw your diameter and connect the dots. If done correctly, this should be congruent bisected, which makes it a rectangle. Any questions on the parallelogram or the rectangle by diagonals? All right, let's go to the rhombus by diagonals. What do we know about the rhombus diagonals? First of all, is it a parallelogram? Yes, so we know the diagonals are bisected. Second, good, I was going to go for the other one first. Are the diagonals congruent? No, rectangle is where they go congruent. So rhombus doesn't have to be. But as Kenyon suggested, the diagonals do have a new feature here. Yep. They're perpendicular. So since the diagonals are bisected, can we do our little circle trick? Yep. Start in the center. Get as big a circle as you can. First one's free. Let's give ourselves a diagonal, also known as a diameter in this case. When it says diagonals are not congruent, what does that scream out to me? Good. We need a second circle that has a different radius. So go to the same center, reduce the radius to construct a concentric circle. But now I need the diagonals to be perpendicular. How do we make perpendicular? Yes. I'm going to pick 2 points that are equidistant from the center. In this case, the endpoints of the small circle. From those, I go more than halfway, so just past the center, and make a football. Same from the other side. And when I connect these, I'm only going to connect them as far as the smaller circle. Because I only really want to go there, 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 and there. Connect the dots. And again, in your construction, you should leave notations for what you did. Diagonals are bisected. This one is the same as this one. This one's different, but the same as this one. And there's a right angle. Any questions on the rhombus by diagonals? Okay, what about the square? What's true about their diagonals? All the same? Diagonals are bisected. Are they congruent? Yes, that's what's different. Are they perpendicular? If you're not sure, check that cheat sheet at the end of this. So in other words, we've got the purple thing in my case that is parallelogram based. We've got the green thing, which is rectangle based. And we've got the blue thing that is rhombus based. The square has all of those features. To do the bisect part, let's do our circle. Let's make one diagonal. Because the diagonals are congruent, just one circle. But before I draw this other one, I need them to be perpendicular. So I'm going to have to make a football through this point. Got to make them equidistant from both sides. So I'm going to go from this side more than halfway. And from this side, at the same distance. And connect the dots. We're saying all four half diagonals are the same size and perpendicular. All right, let's construct isosceles trapezoid by diagonals. What do we know about the diagonals of an isosceles trapezoid? Let's start from the top like we did with the parallelograms. Are they bisected? Are they? I thought that was a feature of parallelograms. Trapezoids are not parallelograms. Diagonals are not bisected. Are the diagonals congruent? Check your note sheet. Are the diagonals congruent in my isosceles trapezoid? Yes. Are they perpendicular? Nope. So how do we do this? I still like the idea of the circles. I'm going to make two circles. Do the concentric circles, please. Now, can we agree that every radius that goes from this center to the small circle is the same length? And that every diameter of the small circle is the same length, right? If I come out of the center, go through the small circle and get to the big circle, is that the same as if I do the same over here? So I need my diagonals to be not bisected. The easiest way to do that would be to go from the short circle on top through the center to the long circle. Can we agree that that is not bisected by that center point? And if I do that same thing from somewhere else on the circle, will it have the same length? Because it's the combination of one radius of the big and one radius of the little. So wouldn't that add up to the same? The diagonals are congruent, but they're not bisected. Connect the dots. Is that an isosceles trapezoid? Are we sure? Why? So I'm going to go off on a little tangent here for a second. You guys know that you are going to be selecting classes soon, right? If not already done it. One of those is going to be your math class. And you have four choices, really. If you're a freshman and you didn't do well in algebra, I will give you feedback on that when we get these things graded, the algebra skill surveys. You can go back and take Algebra 1 again. Get a really strong foundation. COVID didn't give you a fair shake. Get that solid. You'll have success the rest. 2, you're a sophomore or junior. You didn't get a good algebra foundation. You should go into intermediate algebra. You need a little bit slower course next year. You don't want to have this super challenging, high expectation math course because that's going to bury you. Intermediate algebra is still UC qualified. It'll still let you apply to all the schools you want to apply to. It just means you're not aiming for calculus, right? You're going to be an English major or history major or social sciences major, or human biology or something like that. Probably not hardcore chemical engineering, probably not math, computer programming. On the other hand, you may want that. You are a math person. You're going to kick butt and take names next year and take advanced algebra, leaving you with a path to get to calculus. Fourth choice is, that's all good, but you love math. This is what you do first. And when I ask, how do you know if this is a isosceles trapezoid, you begin to spin through all the knowledge we've had. You ask yourself what you know, what you can do. You look at these triangles and identify that these triangles have side, angle, side, side, angle, side. So these triangles are congruent. That can get a CP, CTC to say these sides are congruent. You dig deep in math, in which case you might be a really good candidate for honors advanced algebra. Now, everyone will be invited to honors advanced algebra who had a B or better in geometry. So soon enough, you'll put in your request, you'll apply for advanced algebra. Then about 4 weeks later, you get an email that says, because you got a B or better in geometry, you can try for advanced algebra honors. Just sign this form and come back, and then you're in advanced algebra honors. Two things to know about that. One, I will be giving you feedback that tells you how your algebra skills are. And if they're weak now, you should get them fixed before you go into algebra, advanced algebra, especially if you go into advanced algebra honors. Two, next year, for the first time in I don't know how long, honors advanced algebra will not be a 5-point A. You will not get a grade boost. If you're thinking that a B in honors advanced algebra is equivalent to an A in advanced algebra, it's not. You're getting a B in honors advanced algebra. Is that going to be looked upon favorably by colleges? I can't speak for all of them. I would say there are some math, science heavy colleges who would respect that you took a harder load. I would say there are some colleges that don't care. If you're looking at some big university out somewhere in the Midwest and they're just doing your GPA, they would say a B from honors advanced algebra is less good than an A from advanced algebra. Question? I don't. It is the case for all math. Yes.
All math in the country, or?
No, just in our school district. Okay, last one. We're going to construct a kite by the diagonals. Do you guys know what the kite diagonal scenario is? No. Flip it over and let's take a look. Diagonals are perpendicular. Now, please listen. What we're going to see in kites is that this side is the same as this side is the same as this side, and this center side is reflexive. So what you see is that these two triangles end up being congruent, which means this shape has symmetry. If you were to fold the top over the bottom, they would exactly match up, which tells us that this little angle here and this little angle are the same. It bisects that angle. This angle over here and this angle over here are the same. It bisects that angle. These angles are not bisected. However, they are congruent. And this part and this part, these two little diagonal pairs, these two are bisected, these two are not. So what we're going to say in our diagonals is one diagonal is bisected. Diagonals are not congruent. But diagonals are perpendicular. So because one diagonal is bisected, we should do our little circle thing. That first diagonal, let's just draw it all the way through. The other one is perpendicular. And this one has to be bisected. So it has to go through this spot and be perpendicular. So I'm going to go with from the end point here, more than halfway. From the end point here, more than halfway, the same distance. Now, if I go all the way to the end here, I'm going to create what shape? A square. I don't want a square. And the difference is I don't want these two diagonals to be the same length. So the easiest way to do that would be to say, I'm going to put a point here that's inside my football head here. And I'll put a point here that's outside my football head here. By doing that, I know that these two are not bisected. Well, this one is bisected. Connect the dots. Any questions on constructing this stuff? Your homework tonight is this page of kites. I'm going to give you a question mark. This line was already drawn, and I chose one that was inside of the football and one that was outside of the football. That way, knowing these line lengths are different. Exactly where it doesn't matter. Yep. Okay, let me take you through just a couple of these kites. Looking at this one, as I said, one pair of angles is congruent, the other pair is bisected. Which pair of angles here are congruent? B and D. Therefore, let's call it X and X. What do I know about all four of these angles together? Yep, so 85 plus 43 plus 2x equals 360. I'll leave you to finish that one. What about number 2 here? Which angles are congruent? J and L. So if that was 82, so is this one. And I could do the 360 thing to find K, right? Okay, let's take a look at number 5. Which angles are congruent? 1 and 2 are. These are not, because this is not parallel. So this is the pair that's bisected, right? It looks to me like these are the same and these are the same. So the triangle on top folds over this triangle, making these the same. 1 and 2 are the same. 52 and 7 are the same. So number 7 is 52 degrees. 65 will map right down onto 4. So 4 is 65. How big is 3? 90. It is 90 degrees because diagonals are perpendicular. And if I've got 90 degrees and I've got 65 degrees, can I find 2? And will that find 1? And if I have 1 and 2 and 7 and 52, can I find these other ones? I can. You have the rest of the period to work on this. This is your homework.